Okay, so you have made it to the end of the chapter. This is 14.2 day 1, sinusoid constructions. It is very similar to what we did during the last class, so it should look vaguely familiar. We're not going to work on the lab today. We are going to kind of look at it. We'll work on the lab the next time we get together for our review for the test. And we've decided the test is going to happen on the 23rd and the 24th of this month. Okay, so next week. We are going to do something called the Daylight Lab. You're going to research, and the next time we get together, I'll give you a website to go on the length of a day in a city that you'd like to check out. So different places around the world, what's the longest day and what's the shortest day. You're going to construct a cosine curve and make a model for a full year of daylight for that particular city. And then we're going to talk about what is your prediction for locations around the world, what kind of length of day they would have. Okay, but that is to happen the next time we're together. So today we're going to be given a word problem and we're going to construct a model for it. We've exclusively been using cosine, but you can also use sine. So I really like this problem because we're going to be able to tackle both in one problem. So Dwayne is riding a Ferris wheel. The Ferris wheel boards at 10 feet from the ground and the radius is 35 feet. Takes 5 minutes to complete one revolution. We're going to write a sine and a cosine model for this Ferris wheel. Okay, so let's graph it first to get an idea of what this looks like. So it looks like the bottom of the Ferris wheel is at 10 feet. And then we need to, so that's the minimum, and then we need to find the max. Well, if the radius of this was 35, that means this radius is also 35. So if this is at 10 feet, 35 plus 35 is 70, so that means that the top is at 80 feet. So mark this as 80. Okay. You guys know I like to start with my midline. So if you take the min and add the max and divide by 2, we're finding the average. You get 45. So I'm going to make my midline at 45. Okay, that also means that I'm going to add 45 to both of these functions. That won't change. Cosine or sine, doesn't matter. The midline's still 45. Okay, next I'm going to find the amplitude. So I think the amplitude is the midline to the max from the midline to the min. You can see that on our Ferris wheel that it is 35. That goes for cosine and it goes for sine. Now we have to figure out the period. It said in the problem that the period for this function is 5 seconds. So we need to figure out b. So that means 2 pi over b is now equal to 5 seconds. If we multiply by b and divide by 5, b ends up being 2 pi over 5. That is going to be the same for cosine and for sine. Okay, so I'm going to graph this. My Ferris wheel starts at 10 and it ends at 10 after 5 seconds. So I'm going to have to find my intervals by dividing 5 by 4. Take the period and divide it by 4 and you'll find your interval. So that would be 5/4, 10/4, 15/4, and I need to erase this 5. It's not quite right. There we go. And 20/4, which would be 5 seconds. Then we're back at the bottom. So we're at the midline at 5/4, at the top 10/4, midline at 15/4, and 20. So there's my function. Okay. Right away, I see an upside down cosine curve. So I'm going to deal with the cosine function first. So I think this is negative 30. Let's get some y equals. Negative 35 because it's upside down. And I don't see a phase shift because it starts at 0. So I'm going to do t minus 0 here for my cosine function. Now that's not the only cosine function. You could say that cosine starts here. And it would then be positive. Here, I'll write that down here. Y equals positive 35 cosine 2 pi over 5. And you could do a phase shift of, that looks like 10 pi over 4. I'm just 10 over 4, sorry, or 5 halves. plus 45, that's also a sinusoidal model for the exact same curve. So there are infinite ways to model this curve. So we've done cosine, let's do sine. So I think if I were to find a sine wave within this wave, or a sine function, I think, and I'll do it in green, I'll draw right over the top, I think this looks like a sine function. And if I wanted to use that, it looks like positive sine, and at the phase shift, it would start here. The phase shift would be negative 5/2. That looks like minus minus. So it would just be t minus 5/2. Okay, so you have homework to do. That's the only example I have, because the homework is short. So you've got another Ferris wheel question, are 3 and 5, and I will post a key for this. We'll review the next meeting we have together, and then we'll test next week this time. Thanks, guys. A yo-yo questions for this homework question. And then this is a question that's similar to the homework from yesterday. And it won't let me zoom in. But you are going to pick the high and the low, and you're going to make a sinusoid. I would recommend doing cosine just because that's similar to what we're going to do for the lab. And then you're going to do B, C, and D. So the only